Number 6, an isosceles triangle. Isosceles means at least two sides have the same length. Has its vertex at the origin. That's referring to its vertex angle. That's right here. Its base, the base is the side that is opposite the vertex angle. So this is the base. Is parallel to and above the x-axis, like so. I wouldn't add all this to the picture. I'm just explaining it to you. And the vertices of its base, which is here and here, is on the parabola. And the name of that parabola is f of x equals 27 minus x squared. So we are supposed to find the area of the largest triangle. Largest meaning the largest area. Part A, label the picture. Here's how I would label this picture. Since we're supposed to find area of a triangle is 1/2 the base times the height. So we need to figure out what the base and height are of this triangle. Since this is an x value, it means that we have gone from the y-axis to the right x units. It means this entire base, it's x to the right and x to the left. So this is x and this is x. It makes this whole length 2x. That's the base of the triangle. Well, what is the height of the triangle? This is the height that you see here. It's called an altitude. And that is exactly y units above the x-axis. And y units, in this context, is the name of the function 27 minus x squared. So when it says to label the picture, this is how I would label it. And the important things, once again, that we have the base and the height, because we need those to find the area. So that's part A. Part B, express A, the area of the triangle, as a function of x. What is the domain of A? So there's multiple parts of this. So express the area, and what is the domain? There's two parts to this. So the area, once again, is, I'll just do some work for this up here. Well, we already got this up here, so let's just go all the way up here. The area is 1/2 the base. We're saying the base is 2x times the height, which is 27 minus x squared. When it says express it as a function of x, it means we can't have any variables in this but x. Half of 2 is 1, so it's 1 times x. If you distribute the x, we get 27x minus x cubed. So that represents the area of this triangle. There's variables in it because depending on where this x value is, it's going to depend on what the shape is, and it's just going to change the area. So what's the domain? What x values can we put in? Well, I think that you would agree that if we put an x value in of 0, that means that this thing would be all the way up here, and this would end up being the entire shape, which is not a triangle at all. If you followed this curve and you went, let's do this. Not trying to insult you by any of this, I'm just not sure where you are on this. If the x value was all the way down to here, we also wouldn't have a triangle because there's no height. So the domain for this is going to be an x value that's bigger than 0, and it goes to the x-intercept, whatever this x value is. To find that x-intercept, we take the original function. This is the work for this. F of x equals 27 minus x squared. Set it equal to 0, which means you're saying the y value is 0. We're trying to find the value of the x value. If you square root both sides, you get plus or minus 27, which makes sense because we have a positive and negative x-intercept. This reduces to plus or minus 3 square roots of 3. So our domain for what x could be in this function, x could go from 0 or it could go to 3 square roots of 3. Finish the problem. So find this maximum area, and there's not a ton of work not a ton of space here to do this work. To find the volume, I'm sorry, we're not doing volume, we're doing area. To find the area, take the area function, which we said was 27x minus x cubed. To find the maximum area, which is what we were supposed to do originally, up here, find the largest area of this triangle. We're going to take the derivative. Remember the derivative, if you set it equal to 0, finds max and mins. We're trying to find a max. We're going to get 27 minus 3x squared. So now we're going to find critical values by setting this equal to 0. And we end up with x could be positive or negative 3. Which really means we're saying x is going to have to be a 3. If you go up here and you put a negative 3 in, that's just over here on the left side. But I'm defining x as the positive length going over here. So I guess maybe you could make an argument that this domain goes from negative 3 square roots of 3 to positive 3 square roots of 3. I don't think that you would make that argument, though. I think we're going to stick with that. How would we know for certain this is a max? Well, you could use a second derivative test. Find the second derivative of this, which is going to be negative 6x. And then the second derivative test, if you put a negative 3 into this, will your answer be positive or negative? It's negative. If it's negative, it's concave down. If it's concave down, it's a maximum. I assume you would have to show this. Second derivative test, I know you do in my classroom. So we haven't fully answered the question, but what we do know now is that the 3 is the x value we're going to use to find the maximum area of this triangle. So the question actually was, what is the largest area? So once we know that we're going to use a 3, this is a critical value, we take the original function and we replace the x in it with a 3 to find this maximum area. 27 times 3, I'm terrible with math. 71, that doesn't sound right. 91, that sounds better. 3 cubed is 27. 91 minus 27 is 64. So assuming that I multiplied and subtracted right, all this work, I don't know how you could possibly fit all this stuff into that small space up here. But this is all work for part C. And I would write the answer as the maximum, the largest, I'm going to use the same language as in the problem. The largest area of the triangle is 64 square units. We weren't given a scale, I don't think. With a base being x equals 6 units. Why is it 6? Once again, 3 represents the x value. The x value goes from here to here. The base is twice that long. If you want to also give a height, you could. I don't think you need to do that, though. For sure, in your answer, you need to say the largest area of the triangle is 64 square units. So that concludes that. Hopefully you found this to be helpful. And if it wasn't, I'm really sorry. If you got questions, hit me up.